Now let's present about the wine classification using neural network pattern recognition toolbox in the Matlab.
Now moving on to the introduction. So this wine classification actually involves classifying wines from different wineries based on their chemical properties. Each wine is categorized by set of 30 attributes, which includes alcohol content, malic acid, ash, alkalinity of ash, magnesium, total phenols, flavonoid, non-flavonoid phenols, color intensity, hue, OD 280/OD 315 of diluted wines and proline. So, this case study focused on building a neural network to classify wines from 3 distinct wineries using these attributes. So, the goal is to achieve high classification accuracy. Unknown wine samples also ensure model ability to generalize to new and unseen samples.
Let me present about the detailed description about data. Actually, the data set is already available within the Matlab. So we use some commands in the Matlab to extract the how many data set, how many rows and columns available within the data set. So for each instance in the dataset is associated with a target label indicating the cultivar of the wine. The target variable has 3 distinct classes corresponding to the 3 different cultivars. The distribution of these instances across 3 classes is slightly imbalanced, with 59 instances in class 1, 71 examples in class 2, and 48 in class 3. The input matrix contains the feature values for all 178 wine samples. So there are 13 features in the wine data set, starting from the alcohol to the proline. Now let's extract the data set to know how many columns and how many rows are there in the data set. Okay, first I use this is the link. Okay, here they already provide the data set. In this example, we attempt to build a neural network that can classify wines from 3 wineries by 13 attributes. Okay, in this documentation, they already provide some command line here. So I use this command line to know the data set lah. So these lines are very important. So okay. So these are the lines from the documentation. Okay, let me run. Okay, so this is the answer. So there are 13 attributes with 178 samples, and these are the number of classes. So we have 3 type of wines: type 1, type 2, and type 3, and with the 178 samples. So, okay, thank you.
Now let's go through with the flowchart of our project. So first we will start by loading example data and choose the data wine set data set. Next we will move on to the set the amount of data for training, validation and testing. After that we will set the number of hidden neurons. Then we will proceed to start the data training. Later on we will check the result of the training. If the results of the training is good, then we will end the program. If it's not good or false, then we will go back to the set the amount of data for training and validation testing, then go through the process again until we get a good training. That's all.
Let me show the how to use the toolbox in the Matlab. First, let's open the online Matlab. Now let's go to apps. Okay, under machine learning and deep learning, let's click the neural network pattern recognition. Okay, it already appear on in a new window. Okay, let's enlarge it. Alright, okay. So let's import the data set which is already available within the Matlab. Let's click it, and it will take time to upload. Alright, so this is the network diagram. Okay, so two-layer feed-forward network with sigmoid hidden neurons and softmax output neurons suitable for classification task. Okay, here these are the default parameters with training data 70%, validation data as 15, test data 15, and layer size is 10 euro. Okay, now let's train the data. Okay, alright, this is the training result, and okay, this is the training state. I can enlarge it, I can zoom in. Okay, and this is the performance. I can move this graph, and I can see the x value and y value. Okay, and this is the confusion matrix. Okay, and this is the ROC curve. So for the algorithm, the data division is collected by random, and the training algorithm is a scaled conjugate gradient, and the performance is cross entropy error. So here it says the layer size is 10 because we already set as 10 here. Okay, and so the four outputs will be explained by my teammates later on. Thank you.
So let's look at the step-by-step learning and analysis of this program. First, we need to click the icon of neural network pattern recognition toolbox under machine learning and deep learning, and it will open a new window. Later on, we need to do the importation of one dataset which are available in Matlab. Then let's train the model using the default parameters. So for the training dataset we use 70%, validation data we use 15, test data we use 15, and layer size we use 10 layer, and it shows the training result like the figure 4.3. A network architecture will appear after we click on the network button as we circled, and then when we can evaluate the performance on the training state by clicking on the training state icon. Now let's get the best validation performance by clicking on the performance icon to get the best validation performance graph. Later on, to get a confusion matrix after we train the model, we need to click on the confusion matrix icon. To see the ROC curve, we need to click on the ROC curve icon, and we will be displayed by training ROC, validation ROC, test ROC, and all ROC.
To design a model, we need to go through 6 stages, which are data preparation, design neural network, training, validation, testing, and lastly, prediction. So first, we need to prepare data to separate features and labels, to convert the labels into categorical form, to split the data into training, validation, and test set. Next, we designed neural network. We defined using pattern net function comprises into input, hidden, and output layers. So we use softmax function to multi-class classification. Then we train the model by adjusting network weights to minimize cross entropy loss. Next, in validation phase, we monitor network performance to detect any overfitting and also allows early stop if performance degrades. In the testing phase, utilizes test set for generalization, performance assessment, and metrics like accuracy used for evaluation. For the final stage, we pass some sample features and it will predict which class the wine sample belongs to, whether it is type 1, 2, or 3.
Network diagram. This is a summary of neural network training process and result. First are the training result, which indicates the training process has completed successfully and meet the special validation criterion. The table summarizes the progress of the training in terms of various metrics. Epoch, the training stopped at the 18th epoch. Target was 1000 epoch, but early stopping criteria were met, halting the process earlier. Elapsed time, the total time taken for training was 1 second. Performance, the performance metrics for the classification program started at 0.386 and improved to 0.000138 by the end of the training. For gradient, the gradient decreased from an initial value of 0.287 to 0.000336, showing that the network weight have been optimized. Validation checks, the training process are 6 validation checks with the target value. For the validation checks are typically used to monitor the performance of the model on the validation set and prevent overfitting by implementing early stopping. For training algorithm, the data was divided randomly for training, validation, and testing using the divide rand function. The network was trained using scaled conjugate gradient SGC algorithm training SGC. The performance was measured using the cross entropy loss function. Matlab executable was used for calculation, which is a way of optimizing performance in Matlab. This shows the network diagram. This provides a summary of the neutral network training process and result. First are the training result, which indicates that the training process has completed successfully and met a special validation criterion. The table summarizes the progress of the training in terms of various metrics. Epoch, the training stopped at the 18th epoch. The target was 1000 epoch, but early stopping criteria were met, halting the process early. So now let's explore the performance plot. So the blue line represents the cross entropy error for the training data, our epoch, while the green line represents the cross entropy error for the validation data, our epoch. So the best validation performance is indicated by the green circle, which occurs at epoch 9 with the cross entropy error 0.045576. So the red line represents the cross entropy error for the test data, our epoch. So the test error is used to evaluate generalization capability of network after training. So The best performance, the plot highlights the best validation performance at the epoch 9, where the error entropy error is lowest 0.045576. This is a critical point indicating the optimal model performance before potential overfitting occurs. So now let's explore the training set plot. So the first plot shows the gradient of training set process over epoch. The gradient represents how much the weights are adjusted during training. A lower gradient indicates that the training process is approaching convergence, and the second plot shows the validation checks over epoch. Validation check help to determine when to stop training to prevent overfitting. The network stops the training when the validation error increases consistently. So, the network is trained using 70% of the data, validated 50% and tested with 15%. So, the training stopped at epoch 15. Due to the validation performance is not improving. So, the cross entropy error for training, validation and testing is very low, indicating a good model performance.
Okay, today I would like to explain about the error histogram. So the blue error indicates the errors from the training dataset. The green errors indicate the errors from validation dataset, while the red error indicates the error from the test dataset. The orange line indicates zero error, the point where the predicted output is perfectly matched with the targeted value. As you can see, I would like to explain about the error distribution. Most errors are centered around 0, indicating most of the predictions are close to the targeted values. The highest concentration of instance in the bin is centered around 0.00702, which is actually a very tiny and minor difference from 0, suggesting a slight bias where the model's prediction are slightly lower than the actual value. The training errors are the most numerous and primarily fall within the central bin, suggesting that the model has learned to predict the training data quite accurately and also perfectly. And the validation errors are fewer but still centered around the 0, indicating that the model is generalizing reasonably well to unseen validation data, as it also predicts the system quite good actually. And also the test errors, which are the red, are the least numerous but also centered around 0, showing that the model's performance and its accuracy on completely unseen test data is comparable to the performance of the training data set and also validation data set used. It shows that the error in the particular system is quite low and the system is just very minorly biased as it should be, so that it does not give a very high percentage of accuracy. Yep, thank you. Today I would like to speak about the confusion matrix. The confusion matrix in the graphic has given an illustration on how well the neural network model performs when used for classification. The confusion matrix contrasts the model's predicted classification, which is the output value, and also the actual classification, which is the targeted value. It seems that the model in this instance is intended to categorize numbers between 0, 1, 2 and 3, and actually it's 0, 1, 2, 3 indicates the type of class. The confusion matrix indicates the frequency with which the model predicted an output class, while the actual class was a targeted class. Each item in the matrix indicates the number of times this occurred. For instance, the top left cell displays the number of times the model correctly predicted class 1 when the actual class was 0. The model properly categorized class 3 100% of time, as the bottom right cell demonstrates it. Most of the entries should ideally lie along the diagonal, signifying that the data was accurately classified by the model. In this instance, the model did well when it comes to class 0, 2 and 3, but it had a trouble accurately classifying class 1 with the proper calculation of 3359 out of 3400 data points. The model's overall accuracy was around 98.6. The figure above shows the training ROC, validation ROC, test ROC, and also the all ROC. To determine whether the ROC graph is good or not, the further to the upper left the line is, the fewer false positive you need to accept to achieve a high true positive rate. So the best classifier is one where the line goes from lower left to upper left to upper right, or something close to the above pattern as you can see in the figure. Okay, the figure above shows the receiving operator characteristic. Actually, this type of chart is used in machine learning to measure the performance of a system that classifies things into two categories. In this case of this ROC plot, it appears to be evaluating a system designed to clarify wine types. The x-axis of the chart is labeled false positive rate, and y-axis is labeled true positive rate. A point at 0, 1 would indicate a perfect classifier, one that identifies all positive cases correctly, true positive rate of 1 with no false positive rate of 0. Points further from 0 and 1 indicate classifiers with worse performance. The diagonal line shows the performance of a random classifier, one that guesses classification with a 50-50 chance of being correct. The further a curve is above the random classifier line, better the performance of the model, as we say. Thank you.
We also tried coding part. So this is the complete workflow for training and evaluating a pattern recognition neural network in Matlab. So it includes loading a dataset, creating and visualizing a neural network, training the network, testing the network, and evaluating its performance using conversion metrics and ROC curves. So the results provide insights into the accuracy and effectiveness of the neural network for the classification task. The results have shown in the findings and the results section. So below that it shows the percentage correct classification, and then it shows 100% and incorrect is 0%. First load and prepare a dataset, and then we train the neural network with the dataset. Then we prepare a new dataset in the same format as the training data. So here it shows that like for new wine data we shows 13.2% of alcohol, and we choose a random number between the ranges for each features, and then we type it here, and then we normalize the new data if the training data was normalized, and then we use the training network to predict the class of the new data. So then it converts the network's output to a class index, and it displays the predicted class. So here it shows the in the command window it displays the predicted class for the new wine dataset is type 2.
As a conclusion, I want to state that this is one of a useful method for differentiating between various wine kinds based on their chemical properties, and other pertinent factors has been the development and implementation of wine classification system in Matlab. This system is an excellent option for both academic and industry applications in the fields of enology and viticulture, since it makes use of the powerful computational capabilities adaptable toolbox offered by Matlab. So at the beginning we pre-process the data, then we select algorithm, then we did validation and training models, then we evaluate the performance of the model using metric of the performance such as ROC, area under the graph and stuff, and after that we illustrate the model through graphical representation in Matlab, such as scatter plots and also ROC curves. Then finally, for the future directions part, I would say we could integrate with IoT and sensor, as real-time data for more dynamic and accurate classification can be obtained by integrating the classification system with IoT devices and sensors in vineyards and wineries. Secondly, we can try to improve the algorithm, investigating more sophisticated deep learning, machine learning methods can handle increasingly complicated data sets and increase classification accuracy. And finally, it should be have a user-friendly interface. Creating graphical user interfaces GUIs in Matlab can help people with limited programming or data analysis experience more easily navigate the system. Thank you.